Professor Bengio is the world-leading expert on deep learning and author of 3 books and more than 300 publications. He's among one of the most cited Canadian computer scientists and is active as an associate editor of the top journals in machine learning and neural networks. His research objective is to understand the mathematical and computational principles that give rise to intelligence through learning. He has contributed to a wide spectrum of machine learning areas and is well known for his theoretical results on recurrent neural networks, kernel machines, distributed representation, depth of neural architectures, and the optimization challenge of deep learning. His work was absolutely crucial in advancing how deep networks are trained, how neural networks can learn vector embeddings for words, how to perform machine translation with deep learning. In 2018, Professor Bengio was awarded the Turing Prize, which is the Nobel Prize of Computing, for his work developing the AI subfield of deep learning. Professor Bengio is full professor of the Department of Computer Science and Operation Research at the University of Montreal. He's the head and the founder of the Montreal Institute for Learning Algorithm, the MILA. He's director of scientific program of the Institute for Data Valorization, IVADO, co-director of the Canadian Institute for Advanced Research CIFAR program on learning in machines and brains, and Canada Research Chair in Statistical Learning Algorithm. Without further ado, Professor Bengio.
Hi, everyone. Do you hear me? Yes. Okay.
Yes.
So I'm going to try to answer the questions that were asked to me about AI and so what's up that some people might enjoy or take advantage of in what's new. The field of AI is driven by a rapidly growing set of advances in machine learning, and as many of you know, a lot of that is anchored in deep learning, the area that I contributed to, but a lot also comes from reinforcement learning, for example, and related questions that come from machines that interact with their environment. Well, this morning I'll only touch 2 or 3 topics briefly. One area that I think will matter more and more to industry is the study of the challenge of out-of-distribution generalization. So what does that mean? What happens when you train a machine learning system on data that's coming from some environment, but then you're going to deploy it in a different environment? For example, you train from data from one country or a few countries, but are you going to be deploying in other countries where maybe the culture is different? Maybe you collect data from some hospitals and they use different machines from the ones that you've been training on. And then what happens is that your industrial deployment seems to work in the lab tests, but it doesn't work in the field. That you get a hit. So this is a problem that many people in machine learning research these days are investigating. A number of algorithms have been proposed, theories, and I don't think we have the answer to this, but the field is moving fast. So I encourage you to keep an eye on this. My own group has been exploring how concepts in causality and inspiration from system to human cognition can drive the design of new machine learning approaches to deal with that challenge. So this is something I'm investing in personally. Another area I want to highlight quickly is a completely different scope that I became really involved in because of the pandemic, is that of applications of machine learning in the pharmaceutical industry. So of course, there's more and more AI in healthcare, but especially I think in this industry, there's a conjunction of 2 lines of advances that I think are likely to create a major disruption. So on the one hand, there's been advances in biotechnology, instrumentation, synthetic biology, robotics, that make it more and more possible and cheaper to acquire very large quantities of data. Of course, that makes it much more feasible and interesting to apply machine learning. At the same time, there's been progress in machine learning that are really relevant to some of the questions people ask in this sector. Of course, research in representation learning, graph neural nets for molecules, active learning for going through a series of assays and guessing what you should try next. Bayesian optimization, which is related to that, reinforcement learning, exploration, meta learning. So there is a possibility that in the next few years, the problem of drug discovery is going to be greatly transformed by these tools in terms of cost, speed, quality of the candidate solutions, and so on. And the pandemic has awakened many of us, including myself, to the need for that. So what's also interesting is that the machine learning tools that are being developed for that can be applied in many other sectors where you want to search for a needle in a haystack, and you can interact with some system that may be expensive, but that can give us approximate answers. Last words on a completely different kind of topic are about regulation. Many countries and international organizations like the OECD are in the process of drafting responsible AI regulations to protect the public, minimize discrimination and other potentially negative social impact of deployed AI systems. And I think that companies should really consider that in their plans, rather than go for the traditional free-for-all attitude in information technology that has been the rule in the last few decades. Because otherwise they might be in for a lot of bad surprises and wasted efforts, maybe designing products that will be banned or severely restricted. So if you're really interested in this, I encourage you to have a look at the recently proposed legislation currently in front of the EU Parliament. And that's it for me.